Welcome to question 5. Let's get straight to it. Question 5 reads, students test strips of plastic from a shopping bag. They cut some strips down the bag and they cut some strips across the bag. Just in case anyone has managed to get through all of their lives without working out what across and down means, they've included in a diagram across. You've got a diagram of what across is there and what down is. And they've shown the apparatus. You've got a clamp stand, plastic strips and a load put on to plastic strips. Many of you have done a very similar experiment. The difference you can see from the results in your experiments, you added a load to the bag until it snapped. In this experiment they add different loads to the bag and measure the stretch. You've got load for strips across the bag and then how much it's stretched, and then you've got the load added for strips down the bag and how much it's stretched. Question A says compare the two tables of results. Which of these statements can you conclude from the data? You've got to put a tick in the correct box, and the first statement, the plastic stretched more when pulled down than when pulled across. So let's have a look at down. For example, 500 grams down was 52 stretch, 500 grams across was 107. So that is not correct because it stretched more across than it did down. You can see that for any of the other data points, 42, 86, 31, 65, 9, 22. It stretches more across than down, so the first one is wrong. The size of the force does not affect the amount of stretch. Well, we can see quite simply, bigger force, 500 grams, 52 stretch, 100 grams, only 9 stretch. The size of the force fairly obviously affects the size of the stretch. It took more force to stretch the plastic bag in one direction than the other direction is the third statement. Well, that looks pretty sensible, doesn't it? It took more force to stretch it down than it did to stretch it across, so that looks sensible. Number 4, for the same force the plastic stretched more down than across. Let's have a look. Did it stretch more down at 500 grams? No, it stretched, as we said, it stretched more across than it did down, so that one is wrong as well. Tick in box 3 gets you your first mark for question number 5. And next we are on to everybody's favourite part, the 6 marker. So 5B is a 6 mark question. In the 6 marker it says 3 students talk about their results. First student, Anne, is saying, I think the polymer molecules are arranged so that they all lie in the same direction across the bag, as shown in the diagram. So that's what Anne thinks. Anne thinks they are in the same direction crossways across the bags, as in this diagram. Sue says, I think the diagram is wrong. The polymer molecules are arranged so that they lie in the same direction down the bag. So if you imagine the same diagram rotated 90 degrees with the polymers lying up and down, that's what Sue thinks. John thinks, I think you're both wrong. The polymer molecules are arranged randomly. This is the key bit. You need to read the question carefully. It says decide whether each student is correct or not and show how this explains the data. And the data we're talking about is the data from part A of the question. So you've got to decide whether each student is correct or not. The key bit of science to deciding who is correct, well, let's start with John. John says, I think you are both wrong. The polymer molecules are arranged randomly. This is the easiest bit. If the polymer molecules were arranged randomly, then the stretches would be roughly similar. They are not, so they must be arranged in a particular pattern. So John is wrong. You can say, and quote data from the table. For example, at 500 grams it stretched 107. The across the bag stretched 107, whereas at 500 grams down the bag stretched only 52. This is very different, so John cannot be right. There you have decided that John is wrong, and you've used explain the data in the table. So the key bit of science deciding between Anne and Sue is over here in the mark scheme. More forces need to overcome to pull the molecules away from each other than slide the molecules over each other. So to slide them in a lengthways direction, you need less force than you do to pull them apart from each other. So assuming that this diagram is right, then if less force is needed to slide them to pull them apart, that would be correct, because in our table less force is needed to slide to stretch the bag across than is needed to stretch it down, and that fits with our diagram. Less force is needed to slide the molecules apart than is to pull them apart. So because of this, and must be correct, and you must have got that. That's the key thing. You must have said that and was correct in order to get up to 3 or 4 and 5 or 6 marks. So quite a difficult key bit of science there. Once you had that, you've said and is correct. But talk about the forces between the molecules. More force. Again, quote your data from the table. Quote numbers. And if you said that and is correct, Sue is incorrect, and talked about the forces between the molecules, you should be hopefully getting onto your 6 marks. Do take a look at the mark scheme. There's lots of key points there that you might want to include. And well done for listening to this chemistry mock. I hope it helped. All the best. Bye.